Okay, so in this video we're going to explain where these formulas for the area of a triangle come from. So basically they work for any type of triangle, acute triangles, right triangles, and obtuse triangles. And basically what you need are two sides of the triangle and the angle in between them. So here, if you want the area of this triangle here, you would take 1/2 times little a times little b times the sine of angle C. So these two sides and the sine of the angle between them. Or 1/2 times little a times little c times sine of big B. So little a, little c, and then big B is the angle between them. Or 1/2 times b times c times sine of capital A. So little b, little c, capital A is the angle between them. So again, you just need two sides and the angle between them in order to use this formula. So let's see why this formula is true. So what we're going to do is we're going to explain it for acute triangles, and then for right triangles, and then for obtuse triangles, just to cover all the cases. And it's, for the most part, it's pretty straightforward. Just some kind of tricky stuff with right and obtuse triangles, but nothing too bad. So what we want to do is drop a perpendicular from A down to little a. So perpendicular, and we'll call it H. So let's I'll just fill it in, I guess. Okay, so that's going to be the height of the triangle. So now the area of this triangle is going to be 1/2 times the base times the height. Now the base is A. Okay, so this whole thing here is A. Okay, so this A is the whole base here. So that's 1/2 times A times H. Okay, H is the height. So we know that from geometry, the area of a triangle is 1/2 times the base times the height. Okay, so we see this 1/2 is already coming into play. Now, this height, though, how do we get rid of that H? How do we get this in terms of B's and C's and all that stuff? So let's focus on this right triangle here. What do we see? We see that, well, we have a right triangle, so what if we want to take the sine of angle C? Well, if we take the sine of angle C, then what do we get? We get sine of capital C equals the opposite over the hypotenuse. Here's C, the opposite side is H, and the hypotenuse is B, so this is H over little b. Okay. Now if we solve for H, what do we get? We get little b times the sine of capital C equals H. Okay. So that's pretty much it. We can take this, H equals b sine capital C, so we can take that and stick it into here. So then this becomes 1/2 A, and H is little b times sine of big C. So this H becomes little b times sine of big C. Okay. 1/2 AB sine C. So that's this first formula here. That's where the first one comes from. Now similarly, the one of the other ones here, the second one actually is going to come from. So here we focused on this right triangle here. Now let's cover this one up and focus on this right triangle here. Okay. So this is also a right angle, of course. Straight line and then perpendicular here. So these are both right angles. So now let's cover this up. Okay, cover up this triangle here, and this is still H. Okay, this is still H right here. So covering up this triangle. Now, what if we want to take the sine of angle B? Well, then the sine of angle B is going to be, okay, the sine of angle B is going to be opposite, which is H, divided by the hypotenuse, which is C. So sine of B is little h, or there's only one h, I guess, over little c. Okay, so now we can multiply both sides of this by little c, and we get C sine capital B equals H. Okay, now going back up here, area is 1/2 times A times H. Instead of using this one, we can now use this one, and we can say, okay, H is little c times sine of big B. So let's take that and put it into the formula here. So we could also say area equals 1/2 times A times H. Okay? And then instead of using this one, we can just use this one. So H is C times sine of B. So this becomes 1/2 times A times C sine capital B. Okay? And that's the second formula right here. Okay? 1/2 AC sine B is the area of the triangle. Okay? So that's what's going on there. Now we just got to get this third one. So for acute triangles, it's pretty straightforward. Let's just erase all the markings we made here. And what we're actually going to do is just pretty much the exact same thing, but we'll drop a perpendicular from somewhere else. So let's go ahead and do that. That's A, that's little b. Okay, so now what we're going to do is drop a perpendicular from, oh, let's say B to B. I want to make sure we don't mess this up too bad. Good enough. Okay, so, and we're just going to call this h because it's just another height. Okay, so yeah, it's technically a different h from what we had over here, but that doesn't really matter anymore. So, okay, now what do we have here? So now we're going to do the same thing again. Area equals 1/2. Let's maybe move that up a little bit. Area equals 1/2 times the base. Now the base is b. Okay, so we're going to think of this triangle. Here's the height, so then this is going to be the base. So the base is b, 1/2 times base times height. Okay, b is the base and h is the height. This b, remember, is still this whole thing here. Okay, so now we're trying to establish this formula here, so let's cover this triangle up and just look at this triangle here. So maybe we should label these up here instead. Doesn't really matter though, just to be clear. Okay, so cover this triangle. Now if we want to do the same thing we did before, let's see what sine of A is. Okay, sine of A, this is the right triangle, so sine of A is going to be opposites, which is h, divided by hypotenuse, which is c. So sine of A is opposite, which is h, divided by hypotenuse, which is little c. So multiply both sides by little c, and we get c sine big A equals h. Okay, now we can take this expression and toss it into here. Okay, and then what we get is 1/2 times b times c sine A, because h is c sine A. Okay. So area is 1/2 BC sine of capital A, and notice that's exactly this formula here. So this establishes all three formulas for acute triangles. Okay, so notice this is an acute triangle because all three angles are under 90 degrees. Okay, so that's it for acute triangles. Now let's establish the same thing for right triangles. So right triangles are going to be a little bit quicker because we have a right angle. And you know, a right angle is 90 degrees. And what's nice about that is the sine of 90 degrees is 1, so that actually simplifies things quite a bit. Let's label these in a different color. So this will be A, this will be B, this will be C. So capital letters for angles, lowercase letters for sides. So this side will be little a because it's across from capital A. This side will be little b because it's across from capital B. And this side is little c because it's across from capital C. Okay. Now, we're pretty much just going to do the same thing somewhat that we did. So area is 1/2 times the base times the height. So since it's a right triangle, we can say the base is A and the height is B. We can just say that. So 1/2 times A times B. Okay, we can do that. So area is 1/2 AB, but what about this sine? Where does the sine come into play? Well, notice, as we briefly mentioned earlier, C is a right angle, so sine of C, since C is a right angle, C is 90 degrees, so sine of C is sine of 90 degrees, and remember, sine of 90 degrees is just 1. So we can actually just toss sine of 90 degrees on here, okay? And it's okay to do that because what we just did was we just took this expression, took this equation, area equals 1/2 AB, and we multiplied the right-hand side by 1. And if you multiply by 1, you're not really changing anything. You're not changing anything at all. So that's why it's okay to do that. Now, in practice, you wouldn't really do this because it complicates things a little bit. You would just do 1/2 times A times B. But again, we're just trying to establish these formulas for all three types of triangles, acute, obtuse, and right triangles. So even though it wouldn't make sense to do this in practice, the formula still holds true, and that's just what we're trying to show, is that this formula is valid. Okay? So area is 1/2 AB sine of, well actually we should just say sine of C, because C is 90 degrees in this case. So 1/2 AB sine C, so there's the first formula for right triangle. Now what about the other two? So let's maybe get rid of these just to make some room. Now for the other two, what we're going to do is pretty much, actually just like acute triangles, what we're going to do is drop a perpendicular from angle C to side C. Okay, so perpendicular, could have been a little better, but Okay, so side C, that's this whole side here. Okay, now, and this is going to be h. So, it's really, actually nothing's really going to be different. So we're just going to have area. Nothing's going to be different from the acute case, rather, is what I meant. So area is going to be 1/2 times the base. Okay, now the base is c and the height is h. 1/2 times base times height. Okay. Now, just like we did with acute triangles, what we're going to do is just focus on this, cover this part up, focus on this part over here. Sine of angle B is opposite, which is h, divided by hypotenuse of this smaller right triangle in here, which is a. So sine of angle B is opposite over hypotenuse, h over a. Multiply both sides by a, and we get a sine B equals h. Okay? So h is a times the sine of b, so we can take that and toss it into here, and we get 1/2 c times a sine capital B. Okay? So 1/2 ca sine b, notice that exactly is this. This says ac, this says ca, but it doesn't, you have two numbers, you want to multiply them together, it doesn't matter which order you multiply them in. So it is the same thing as 1/2 ac sine capital B. Okay? Okay. And so that gives us the second formula for right triangles. And likewise, if we want to cover this other triangle up now, okay, cover this guy up here and then just focus on this one, we'll look at sine of capital A. Okay, so sine of capital A is what? It's going to be opposite over hypotenuse. Okay, so here's angle A, and this smaller right triangle here, here's the opposite side, it's h. And then the hypotenuse is b, little b. Multiply both sides by little b, so then we get b sine A equals h. Okay, so then we can go back up to here, area equals 1/2 ch, and we can just stick this in there for h. So h is b sine A, so then this becomes 1/2 c times h. H is b sine A, so this is b sine A. So 1/2 cb sine A, notice that is exactly this, except the b and c are switched, but again, two numbers, multiply them together, it does not matter what order you multiply them in. So this is 1/2 bc sine A. Okay. So that establishes the third formula for right triangles. So that's acute triangles and right triangles covered. Now we want to establish these for obtuse triangles. So for the obtuse case, two of these are going to be exactly the same as before, but one of them is going to be a little bit different. So just to be thorough, we'll go through the two again that are the same, just so that we make sure we cover all the cases. So obtuse triangle. Okay. Yeah, that'll work. All right. So let's go ahead and label these. This is angle A. This is angle B. This is angle C. Okay. And this is going to be side little a because it's across from capital A. This is side little b across from capital B. This is side little c across from capital C. All right, now what we're going to do, just like we've been doing, is drop a perpendicular. Try not to mess this up. Okay, so we have that going. We're going to call that H. And remember, A is this entire side right here. So now, just like before, we're just going to use that formula. Area, not really room up there, area equals 1/2 times the base times the height. The base now is A. Okay, A is this whole base right here. And then the height is just H. So now what we want to do is, let's cover this triangle up and look over here. So we have, if we look at this right triangle, what's the sine of capital C? It's opposite over hypotenuse, H over B. H over little b. So multiply both sides by little b, and we get little b sine big C equals H. Take this, stick it on up into here, and we get 1/2 A H, but H is B sine C, so this becomes B sine C. Okay, and that establishes the first formula for obtuse triangles. Okay, and now let's get the second one there. So what we're going to do is move the labels because we're going to cover up this triangle, or this part of the triangle here, and then we're going to look at sine of angle B. So sine of angle B is opposite over hypotenuse, and the opposite is little h, and the hypotenuse is little c. So sine of angle B is h over c. Okay? So let's write that down. Sine of angle B is h over c. Multiply both sides by c, and we have c sine b equals h. So now going back to here, 1/2 ah. Now we can take this expression for h, c sine b, and stick it on up into here, and then we get 1/2 a times c sine b, because c sine b is h. Okay, and that establishes the second formula for the area of an obtuse triangle. Okay, now one more thing to go, and that'll cover all the cases. So this next one, this one's going to be a little bit different. There's going to be an extra step involved. So let's get rid of all this. And we'll get rid of this. And that. Okay. Let's put that label back. So this was a capital C, this was a little a. Okay, now what we're going to do, so this right here, it's a little c, we'll label that on the inside. Now what we're going to do is drop a perpendicular from angle B down to this other side, but because this is an obtuse triangle, the perpendicular that we drop has to be outside of the triangle. So first of all, what we want to do is extend this triangle here, so extend that. So it's, let's just pretend that this whole thing is straight. It's not quite straight, but close enough, I guess. Then what we want to do is drop this perpendicular. Oh boy. Oh, that could have been a lot worse, I guess. So we'll drop this perpendicular here. So we're dropping a perpendicular from angle B to this other side, but this, since an obtuse triangle, because this is an obtuse triangle, we have to extend this side a little bit out here. Okay, so now this here is our right angle. And we want to be careful about what angle A is, so let's relabel angle A. So angle A is this angle in here. Okay, angle A is that angle right there. Okay, so we have that going on. Okay, now let's go ahead and write that formula down. So the area of this triangle, it's the same exact obtuse triangle we've been looking at. It's 1/2 times the base times the height, but now the base, okay, even though we're dropping the perpendicular out here, the base is still B. Okay, even though we extended this, we don't have to worry about this because this part that we extended, it's not part of the triangle, so it doesn't affect our measurement. Okay, we're only drawing this as sort of a guideline so we can see what's happening. Okay, but B is the base, so 1/2 times the base times the height, which we didn't label, we'll call it H. So just like always, the area of this triangle is 1/2 times the base times the height. Now let's see what we can do about this height. Okay, so now here's what's different is, you know, before we would cover some stuff up and look at sine of angle A, sine of angle B, sine of angle C, but now we can't do really do that because what we have is this right triangle here, and angle A, unfortunately, is out here. But we do have this angle in here, and what's this angle right here? Well, if this is supposed to be a straight line, this whole thing right here is a straight line. Okay, that whole thing right there is a straight line. This angle right here is A, then what's this angle here going to be? Well, the whole thing is a straight line. That means it's 180 degrees, right? So if we take 180 degrees and subtract angle A, that's what we get right here. There's not really enough room to label it, but so here, if this whole thing, the whole straight line is 180 degrees, so all the way around it's 180 degrees, this part right here is A, then what's left over has to be 180 degrees minus A. Okay, we'll zoom in a little bit on that. Because if we take the entire 180 degrees, subtract the angle A, then we're going to get this part left over. Okay, so then what we can say, so basically we have this right triangle now, so we'll just cover up all this mess out here and just focus on this little right triangle in here. So here's a right triangle, here's our right angle, here's side H, and then here's the hypotenuse C, okay? And then we have this angle 180 degrees minus A. So now what we can say is sine of 180 degrees minus A equals what? Well, again, it's just a right triangle, so sine is going to be opposite over hypotenuse. Opposite is H, hypotenuse is C, so this is H over little c. Okay. So again, we're just focusing on this right triangle here, and again, this angle is 180 degrees minus A. Okay. So sine of 180 degrees minus A is opposite over hypotenuse. Opposite is H, hypotenuse is C. So then what we get is multiply both sides by C. We have C sine 180 degrees minus A equals little h. Okay. So now if we go back to this formula, we can plug this in and we'll have 1/2 times B times H. H is C sine 180 degrees minus A. So we have that. Now that's kind of a problem, right? Because that's not exactly what we want. We have 1/2 BC sine 180 degrees minus A, but we want BC sine A, and then the half out here too. But that's not what we have. But that's actually not a problem, because what we can do, if we think back several videos ago, we had those trig formulas. And so here we have a sine of one angle minus another angle. So this is a difference formula. So what was that formula? Well, in general, sine of, let's say, alpha minus beta, just so that I want to use some stuff that we haven't really used yet in this video, just to avoid confusion. So in general, sine of alpha minus beta is sine of alpha cosine of beta minus cosine of alpha sine of beta. Okay. So we're going to use this formula where this 180 degrees is our alpha and capital A is our beta. Okay. So what we have then in our specific case is sine of 180 degrees minus capital A equals sine of 180 degrees times the cosine of A, okay, minus the cosine of 180 degrees times the sine of A. Okay. Now what is that? Well, sine of 180 degrees, that's 0. Cosine of A is just cosine of A. Then we have minus cosine of 180 degrees. What's that? That's -1. And then we're multiplying by sine of A. Okay, so actually what happened here? By the way, these are just 180 degrees. That's a special angle on the unit circle. That's also pi radians. So 180 degrees is pi radians. If it's easier to think about in terms of radians, by all means, go ahead and do that. So sine of pi is 0. Cosine of pi is -1. So 0 times cosine of A goes away. Then we have minus -1 times sine of A. Minus -1 becomes +1, so we just have positive sine of A. So minus -1 times sine of A, just +1 times sine of A, which just means sine of A. So actually what we've just established here is sine of 180 degrees minus A equals sine of A. So actually that's great now, because now we can just say this is 1/2 BC sine of A, because what we've just shown here is sine of 180 degrees minus A is sine of A. So therefore we can just replace this whole part right here with sine of A, and that establishes this third formula for obtuse triangles. Okay, so that's all three formulas for acute triangles, right triangles, and obtuse triangles, and an example coming up of how to use this, an example coming up in the next video.